Okay guys, we're back here for another video in our vlog series here. A little change of pace. What we've been doing is either Fusion 360 tutorials or machining tutorials, but essentially I wanted to continue on with our study of the NIMS curriculum. Okay, and the idea is that whether we get to take the NIMS test or not this year is still a little unknown, but I would like to give you guys, once a week or twice a week, we'll see, but pretty much probably once a week, a lesson from the Cengage textbook that goes along with the NIMS CNC operator test. And where we left off with that whole deal was that you guys had taken the practice test, and then we were kind of reviewing what you guys had gotten wrong on that practice test. Well, we kind of ran out of time to go over some of the lessons that go along with that practice test. Okay, and this is mainly for my CAM class, but DDP is going to be watching this as well, mainly because it's just relevant information for all of my classes, but it really culminates in that CAM class. Okay, so I probably won't get through all of the slides on this. It'll probably take me a couple days to get through this whole lesson with you guys, mainly because I'm trying to keep the videos to about 15 minutes long, just so that you're not sitting there and super bored. So try to keep it short and sweet for this video. Okay, so what we're going to go over here is precision measurement. Most of you are fairly aware of some of the precision measuring tools, but again, this is all about review, making sure that you know what you need to know for the test. I do in this presentation have some videos linked in here, and what I'll do is, along with the video, I will post the link to this lesson so that you can kind of follow along on your own, or if you want to pause and watch one of the other videos linked, you're more than welcome to. And this one that I had linked here is an ABOM79 video, and he does some pretty cool manual machining on this drill chuck tailstock, lathe tailstock quill. And he uses some precision measuring tools in the process of doing so. Okay, so precision measurement is really measurement of tolerances that are smaller than 1/64th or 1/100th of an inch. You could even say 0.5 millimeters. Okay, so pretty much anything that we can't do with a rule or a scale, we would have to use precision measurement for. Oh, and by the way, this little GIF over here is an image of a part that was wire EDM cut. So an EDM machine is an electrical discharge machine, and you basically are taking like a hot knife through butter, and the kerf of the wire is so small that the parts that are remaining that get cut out they fit so well that you can barely even see the seam. How do you measure that kerf? How do you measure that cut area? Well, precision measuring tools can help us get there. Okay, so what is precision measurement? Again, English measurements usually between 1/1000th and 1/10,000th of an inch. Metric measurements 0.01 to 0.002 millimeters. Okay, so there's a language to these precision dimensions that I'm going to go over here in a second. So as you can see, this diagram here shows how we would pronounce some of these measurements. So most people are going to come up to this and say 1.245 inches. Okay, well, really what it is, and how we would say it, is 1 inch 245 thousandths, or just 1 inch 245. If you said either one of those things to somebody who is either in the engineering field or is a machinist or some sort of technician, they would understand what you're saying if you said 1 inch 245 thousandths or just 1 inch 245. Again, here's another example: 137 thousandths or just 137. And then we have 100 thousandths or just 100. This one down here, where we're including that extra decimal place, we have 220 and 4 tenths. So 220 and 4 tenths. Another way that you might hear this spoken is, when this is, say we needed to take off a little bit more material from this measurement. Well, I would say, oh, okay, we need to take off 5 thou or 1 thou. So that, although it sounds kind of funny, is common language in the machining industry. Precision measuring tools are delicate and expensive. You must take care of them, and then calibrating them verifies their accuracy. So most manufacturing companies are going to have kind of a calibration or an inspection on their precision measurement tools, right? They're going to have some sort of schedule set up that will calibrate those tools so that we are absolutely sure that they're accurate. Again, another video clip here you can watch. This is from Mitutoyo on what calibration is and how that's how they go about that. Some precision measuring tools. These are, I would say, almost kind of semi-precision measuring tools, because there's no real output that you can verify. But checking for flatness with a straight edge, you can place these across the surface. If there is a space between it and the surface is not flat. Okay, so if you can see daylight on the other side, we know that the surface is not flat. We have fixed gauges. Okay, so there's a variety of fixed gauges. Pin gauges are one. We have a set of pin gauges at the school. These are usually in increments of 1/1000th of an inch. And the set usually comes, say, from increments of 11 thousandths to 60 thousandths. I believe the set that we have is all the way up to 625 thousandths, or 5/8 of an inch. There's different classes, and these classes represent the accuracy of the gauge. So, obviously, class XXX here is going to be the most accurate, and obviously, along with that, probably the most expensive. We have go, no-go gauges. What these will allow is for you to check sizes of either holes or threads, and one side will be go, and the other side will be no-go. So the go fits either the hole or the thread, and the no-go does not fit. Some more types of gauges here. Ring gauges. Some of this I'm going to kind of skim over. You can, go back. Like I said, I'm going to attach the lesson along with this. You can go back and view the lesson kind of on your own. Along with some of these precision measuring tools, we need to make sure that we have a super flat surface that we can reference these measurements off of. And this comes in the way of surface plates. Okay, they're a flat plate used as an accurate reference for other precision tools. Most of them are made of granite. The one that we have at school is a composite material. Again, sort of semi-precision measurement squares. Okay, this represents a perfect 90-degree angle. We can check perpendicularity with a square. Measuring the error, in perpendicularity with a square on a surface plate with some precision shims. We have gauge blocks. And I think you've seen me demonstrate these gauge blocks where we can actually take them and ring them together, right? Where we bring them in like a T shape or an X shape, and you rotate them and it kind of locks them in place because both surfaces of the gauge block are perfectly flat. And these gauge blocks are, they come in a variety of sizes, known sizes. So if we stack them up, we can get kind of a stack up and come up with a very accurate and, maybe odd size. And we can reference, say another tool off of this. So if we needed, later on in the lesson, we'll get to height gauges. Well, if we need to reference a height gauge to a stack of gauge blocks, right, we can create this stack up, and you can read through here, and this is kind of how you do it. You take the measurement that we need and you subtract the first block until you get to 0, until you've reached that final dimension. But we can reference other tools off of these gauge blocks. So we have vernier measuring tools, okay? And this is going to be kind of the last thing that I go over for this lesson, and we'll continue on with calipers and micrometers in the next one. But with vernier measuring tools, they contain a main scale and a secondary sliding scale called the vernier scale. We can have vernier calipers, height gauges, depth gauges, all sorts of different measuring tools. General concept of, say, a vernier caliper, obviously you guys have seen these external jaws, right? We're measuring the exterior of some, feature, some part. We have the main scale and then the sliding vernier scale. Some different precision measuring tools with vernier scales on them: vernier depth gauge, vernier height gauge. But essentially the concept of these is fairly simple. What we're going to do is on the main scale, okay, we're going to look for our whole inches first, and then we're going to look for 100,000ths of an inch. So we look for our whole inches, our 100,000ths of an inch. Anything that's before the 0 on the vernier scale is what we're going to record first. Okay, so in this case right here, right, in this D example here, you can see there's the 0 on the vernier scale, and here's the main scale. So we do actually have 1 whole inch showing. We're going to look at 100,000ths of an inch, and then we're going to look at 10,000ths of an inch here, and then we're going to come down to our vernier scale and find the line on the vernier scale that best lines up with a line on the main scale. That's going to be in 1,000ths increments, and once we add all those up, the whole inches, the 100,000ths, the 10,000ths, and then the thousandths, we come up with our final measurement. So we have kind of 3 parts there: finding the whole inches, 100,000ths, or 10,000ths that come before the 0 on the vernier scale. Find the line, which is the most difficult part of this, is visually seeing which line lines up best with the main scale. And you take all those measurements and you add them together. Okay, so once again, some different examples of vernier tools. They come in English inches and metric millimeters. Vernier protractor to find angles. Okay, there's several different examples of vernier measuring tools. Okay, so I'm going to try to keep this video down under 15 minutes. Okay, so we will continue with this lesson on Thursday. We'll catch you later, guys.